Hello, everybody, and welcome to our half-day event on hurricanes and health. I am Rachel Nethery. I am a CAFE team member and an associate professor of biostatistics at the Harvard School of Public Health. And I'm excited to be the first one to welcome you to this series of events that we're going to have today. So we're going to be having actually a series today of 4 separate events. The first one is going to be an expert panel, which will start now and last until about 12:30. From 12:30 to 1, we'll be having a speed networking session for attendees. From 1 to 2:15, we'll be having a series of research lightning talks. And then at 2:15 until the end of the session at 3, we'll be having a workshop on the use of an R package for modeling and classifying exposure to hurricanes. So I'm going to go ahead and get us kicked off with this first session, which again is the expert panel. We're very fortunate to have 5 incredible speakers joining us today for this panel. And how it's going to work is we're going to have a series of 15-minute or so talks from each speaker. And then at the end of the session, we'll have a moderated Q&A. So feel free to go ahead and while the speakers are talking, put your questions in the chat and we will put everything together and ask questions to all the speakers at the very end. So I'm actually going to introduce each speaker right before they present, just so you don't forget the speaker details. So I'm going to get us started now with Dr. Arbor Quist, who is going to be our first presenter. She's an assistant professor of epidemiology at Ohio State University, and she's an environmental epidemiologist with a focus on disasters and industrial pollution. She studies health effects of various disasters, including hurricanes, flooding, and industrial disasters. And her research examines how environmental disasters redistribute contaminants and exacerbate health inequities. She received her PhD in epidemiology from the University of North Carolina, Chapel Hill, and completed a postdoctoral fellowship in environmental health at the University of Southern California. Welcome, Dr. Quist. Thank you so much for joining us. I am going to turn it over to you, and I think we should have your slides ready to go.
Awesome. Thanks so much. Great to be here. I'm just going to start us off today by giving us a brief overview of the epidemiological research on hurricanes and health. So next slide. So the health effects of hurricanes are often separated into direct and indirect effects. And the direct effects are caused by the physical forces of hurricanes and direct trauma from the storm. And the indirect effects are caused from unsafe conditions in the aftermath of hurricanes, such as disruption in neuromedical care, injuries during cleanup, impacts from storm-related stress, and damaged drinking water and wastewater infrastructure. And so while direct hurricane effects are typically well documented, indirect impacts are more difficult to assess and often what epi studies are really trying to better understand. So next slide. This is a conceptual model of the direct and indirect health effects of hurricanes from a recent review. So the authors show the direct and indirect linkages between hurricanes, environmental stressors, and human health. And so this includes toxins from water and air pollution and damage to healthcare and housing infrastructure. And it also includes the limited access to medical care, displacement from storms and stress. And so you can see the health impacts from hurricanes are shaped by a complex interplay of factors. One major factor affecting health during hurricanes is the disruption of healthcare delivery. And so often pharmacies and dialysis centers close due to flooding or staffing shortages. And there can be limited preventative care in shelters. And so it's not uncommon for people to have to go to the emergency department just to fill their prescriptions for essential medications. As you know, often hurricanes can cause power outages. Carbon monoxide poisonings occur when generators are used incorrectly and in poorly ventilated spaces. Last summer, after Hurricane Beryl, about 400 Texans were hospitalized for carbon monoxide poisoning, and there are also a few deaths. These power outages also often cause disruption for life-saving medical devices like ventilators or respirators, and also the inability to refrigerate medications during power outages can increase health risks, especially for drugs like insulin that need to be kept within a certain temperature range in order to remain effective. Hurricanes also, they, as you know, often occur in the late summer, and the resulting power outages can increase the risk for heat-related illnesses when air conditioning becomes unavailable. Hurricanes also can cause and exacerbate many environmental health concerns. This can include contaminated floodwater, reduced access to clean drinking water, and mold can also be a big issue, and it's been a major concern of communities that I've worked with. So existing environmental justice and social vulnerabilities can lead to vulnerabilities and inequities after hurricanes. Hurricanes disproportionately affect marginalized communities because of the existing inequities that are exacerbated, including inadequate infrastructure, limited access to healthcare, and greater vulnerability to displacement and pollution. And children and older adults are particularly vulnerable to health health effects from hurricanes. So I'm going to give a brief overview of existing epidemiological research on hurricanes, and this is mostly going to focus on this recent review. And so worldwide, the majority of research on hurricanes and health has been geographically concentrated in the United States, specifically the eastern United States. And in terms of data sources, most studies typically rely on vital records like mortality and birth data or hospital admissions. Methodologically, the most common approaches are time series and case crossover, which are especially great for assessing acute outcomes. And many studies estimate hurricane-related increases in hospitalization by comparing patterns before the storm to those observed during and after the storm. Also, most studies focused on one single high-amplitude hurricane, and that can make it difficult to generalize findings across different types of storms or regions. And in particular, there's been a lot of research on hurricanes Katrina and Sandy. So this is figure from this recent review of 71 papers on health effects of cyclones. And so on the left, you can see that most studies examined exposure windows during the first year after the hurricane. And in fact, the majority of them are really focusing on just like the first month after a hurricane. And on the right, you can see the most commonly examined health outcomes, which include mental health, all-cause mortality and hospitalizations, cardiovascular disease, respiratory diseases, and infectious diseases. So I'll briefly go through some of these most common outcomes. Epi studies often examine all-cause mortality to capture the full scope of health impacts by estimating excess mortality during the months and years after hurricanes. And after some major hurricanes, the increase in all-cause mortality can be elevated for years. Overall, there's a strong association between hurricanes and all-cause hospitalization. A lot of studies also look at mental health outcomes, and there's strong evidence of association for PTSD, anxiety, and depression. And this can occur in the months, usually in the months after hurricanes. Studies also have examined the effects of cardiovascular outcomes in the aftermath of hurricanes, and there's a modest evidence of association. And cardiovascular events related to hurricanes could be from stress from the storm, could be from overexertion during the storm or during cleanup, and could be related to disruption in care. although the specific mechanisms haven't really been well established. A lot of research has also looked at respiratory outcomes related to hurricanes, and there is modest to strong evidence of association for respiratory disease, and this could be from power loss for breathing aids. It could also be due to when there's a hurricane, the heavy wind can blow a lot of particulates, and this can exacerbate respiratory disease. Infectious disease, there's also modest evidence of association for infectious disease and hurricanes, and this could be related to living in close conditions in shelters or from contaminated food or water. And there is also obviously research on injuries after hurricanes, especially drowning, building collapse, and chainsaw injuries after hurricanes. And there's also been a lot of study on diabetes mortality, preterm birth, and cancer, but the evidence is more limited and more inconclusive. So this is a figure of from an analysis of Medicare hospitalizations in the U.S. After tropical cyclones over a 16-year period by Robbie Parks et al. And they examined the increase in hospitalization rates at the county level each day during the week after hurricanes. And so the lag of 0 to 7 days is shown on the y-axis, kind of small, but you can see that there's a strong immediate increase in hospitalizations for respiratory diseases, especially during the first 3 days after hurricane. And there's a slightly longer lag for cardiovascular disease and infectious disease, and no significant increase for cancer or blood diseases. And studies like this are great because they're able to examine many hurricanes together. Although it's also possible that some of these outcomes may differ by region. So I'm going to briefly dive in deeper to talk about waterborne infectious diseases from hurricanes because it's of particular interest to me. Floodwater can contain pathogens, including viruses, bacteria, and protozoa, seen here. And so in the next slide, you can see that pathogens in floodwater can be from damaged wastewater facilities, sewage overflows, landfills, animal waste, dead animals, contaminated runoff. And so flooding can transport pathogens and contaminate floodwater, well water, and municipal water. Then humans can be exposed to various contaminants by direct contact with floodwater, drinking contaminated water, or touching surfaces that came in contact with contaminated floodwater. And the direct contact with floodwater may cause more immediate waterborne infectious disease, and some of the more indirect exposures can cause illness many weeks or months after flooding. And you can see that the pathways of exposure may be different in different areas. For example, in rural areas, more people use septic systems and drink well water, and this can flood and result in higher risk of contaminated drinking water. Environmental contamination issues associated with hurricanes can vary by region, as major industries vary by region. And so the hurricane research I've conducted has been in North Carolina, which is one of the top hurricane-prone states. And it's also the third leading producer of hogs in the U.S., with about 9 million hogs. So hurricane flooding in North Carolina can inundate these hog operations and spread fecal waste and pathogens. And you can see on the left that hurricane flooding and industrial hog operations are located in similar areas in eastern North Carolina. And so in some of my work, I used emergency department data and controlled interrupted time series and observed an increase in gastrointestinal illness, emergency department visit rates after hurricanes Matthew and Florence. And I observed a larger increase after Florence, which was preceded by a dry period, and Hurricane Matthew was preceded by a relatively wet period and dropped less rain than Florence. And so I mentioned this to highlight how different storms in the same region can have different effects. Antecedent rainfall and total storm precipitation can influence the effects that hurricane flooding has on the spread of pathogens and infectious diseases. And this can be explained by the concentration dilution hypothesis. Also, we found that areas with heavy hurricane precipitation and many industrial hog operations were experienced an especially elevated rate of gastrointestinal emergency department visits after Hurricane Florence compared to the expected rates. And so part of this work was to consider how relocating industries that pose environmental health risks from hurricane-prone areas may reduce adverse health effects. Another example of how local industries can influence how hurricanes harm health is this example in Houston. Hurricane Harvey damaged petrochemical facilities in the Houston area, which caused substantial releases of benzene, which is a carcinogen. Superfund sites were also flooded, and that led to additional spread of toxic chemicals. So obviously, hurricanes can harm health, and it makes sense that people want to evacuate before hurricanes hit. But I also want to mention, of course, that there are potential harms from evacuation. Hurricane Rita hit the coast of Louisiana and Texas 3 weeks after Hurricane Katrina. There were like 2.5 million people on the road evacuating, and of the 111 hurricane-related direct deaths, 90 of them were from evacuating. And so this was because of this extreme traffic gridlock. It was extremely hot outside. Drivers limited air conditioning to save on fuel. And people, weren't drinking a lot of water to reduce restroom visits. There's also a bus fire. And so, mentioning this to highlight kind of the complex ways in which hurricanes can affect health. So I'll end by just talking about some of the challenges of hurricane research. One is that there are many different ways to classify hurricane exposure, whether by wind speed, disaster declaration, precipitation, flood extent, distance to hurricane center. And so because of that, it can be difficult to compare studies. Exposure misclassification is also an issue in a lot of hurricane research. A lot of analyses are based on the county or zip code of residents. Also, many people evacuate or are displaced from hurricanes, so it's hard to know when people were exposed to what. And there's also, as I mentioned, differences by storm and location, whether it's recent rain or recent drought, and there's localized exposures in industries. So to conclude, while lots of the research, a lot of research has been done on hurricanes and health, there are still many gaps. Long-term health effects remain poorly understood. The pathways and mechanisms for indirect effects are still relatively unclear. For example, we know that there's an increase in mold after hurricanes, but research hasn't really confirmed how post-hurricane mold affects health. There's also limited research on effects of exposure to multiple hurricanes and limited data and limited studies on vulnerable populations. Thank you all. I really look forward to discussion and lightning talks. There's continues to be a lot of great research on hurricanes and health, and so I look forward to hearing more from any of you today.
Thank you, Dr. Quist. That was a fantastic overview of all that's been done in this space, and so interesting to hear about your own work as well. Very much appreciate such an informative presentation. I think we are right on time. Also, thanks for staying on time. So I will move us right along to next we have Dr. Shuai Wang, who is a tenure track assistant professor of meteorology and climatology in the Department of Geography and Spatial Sciences at the University of Delaware. He completed his PhD in atmospheric science at Imperial College London, and before his current position, he was a postdoc at Princeton and an associate research scientist at NOAA. He also held a research fellowship on environmental management in the School of Finance and Management at the University of London. And his main research interests include extreme weather, climate modeling and downscaling, climate risk assessment, and climate services. Thank you so much for joining us, Dr. Wang. Looking forward to hearing from you. It looks like I can see your slides. Let us know if you have any problems.
Right, thank you. Hello, everyone. So today I will talk about the coastal tropical cyclone frequency on the climate change. So generally, we call this kind of system as tropical cyclones globally, but in different regions, they have different names. For example, over the North Atlantic, we call them hurricanes, and over the Western Pacific, we call them typhoons. So in this talk, I will use these names interchangeably. And this is joint work with Hiro Murakami and Noah, and also Ralph Toomey at Imperial College. So to start, I think this is a good figure just to highlight the importance of hurricane hazard to public health. So this figure was issued by NOAA in 2022. It shows the US billion-dollar weather and climate disasters. And in this year, we have 18 disasters causing direct cost over $1 billion in this year. And as you can see, we have different types of natural disasters like the wildfire, drought, thunderstorms, flooding, and of course, hurricanes. And if you look at the proportion of hurricanes, it's a 3 out of 18. So it's not that high. It's considerable, but not that high. But if you look at the direct cost, so for example, Hurricane Ian this year, the direct cost was about $100 billion. And that's one hurricane event accounts for more than about 70% of the overall billion-dollar disaster cost in this year. And so, of course, I'm cherry picking here. So if I shoot a different year, we'll get a different number. But I think this is a good example just to highlight the importance of hurricane research to public health. Next page, please. Yes, when we think about tropical cyclone hazards, there are 4 types of hazards we need to consider. The first one is intensity. So intensity is measured as the maximum wind speed of the whole hurricane system at a single location. And the second type is hurricane size. Next page, please. So it just shows how big the overall wind footprint is. And next page. The third hazard is the storm surge. So when a hurricane approaches the land, the strong wind stress can push the seawater toward the coast. And once the water goes above the seawall, then we have the flooding. And the last type is rainfall. So these are the 4 main hazards we need to consider in terms of tropical cyclone risk. But actually, on top of these 4 factors, we have one more factor which is more important, that is the coastal tropical cyclone frequency. So if a tropical cyclone does not occur or doesn't approach the coast, then we do not need to worry about any of these hazards like intensity, size, storm surge, or rainfall. So in this talk, I will talk about the coastal tropical cyclone frequency, both globally and in the North Atlantic. Next page. So firstly, let's look at the global average change. And so here we have 3 trends. The first trend, figure A, shows the distance between the nearest land and the location when a tropical cyclone becomes the strongest. So in figure A, for example, in 1 year, if you see, for example, 800, that means in this year, on average, tropical cyclones are 800 kilometers away from the nearest land when they are the strongest. So for this variable, we found a significant negative trend. That means cyclones are getting closer and closer to land when they become the strongest. And for figure B, the second trend is show the fraction of annual tropical cyclone entering the coastal offshore region. And in this year, for example, if you see 50, that means in this year, on average, there are 50% of tropical cyclones entering this coastal offshore region. And for this variable, we found a significant positive trend. So this means more and more tropical cyclones are getting close to the coast. And the last trend showing figure C, so it shows the time fraction of annual mean cyclone lifespan spent in the coastal offshore region. And for example, in 1 year, if in figure C, if you see 20, that means in this year, on average, tropical cyclones spend 20% of their lifetime in the coastal offshore region. And for this variable, we found a significant positive trend. So that means cyclones are spending longer and longer in coastal region. So it seems these three trends paint a big picture showing a landward migration of tropical cyclone globally. But here we need to be careful because for these three trends, we use 200 kilometers to define the coastal offshore region. And we need to double check if this 200 kilometer is a magic number. Next page. So in the left-hand side figure, we are looking at the trend by relaxing the distance to define the coastal offshore region. For example, if we use 200 kilometers to define the coastal region, then every 10 years, we see about 2 more tropical cyclones appearing in the coastal area. And if we relax this distance all the way to 2,000 kilometers, which means we just look at the general trend in tropical cyclone frequency globally, then we don't see any trend. So this really highlights this landward migration of tropical cyclone activity together with the previous three trends in the past few decades. So after we finish this study, and we still have one question left. So human or nature? So we need to find out what's the cause for this landward migration or the general changes in coastal tropical cyclone frequency. Next page, please. So here we only look at the coastal region, and in the following analysis, I will only show these coastal areas in the Pacific and in the North Atlantic. Next page. So the method we use is called large ensemble climate simulation, and we focus on the ensemble mean. We know that our climate is changing all the time, and there are different causes. So one factor is internal climate variability. So these variabilities exist with or without our human beings. So for example, ENSO or like the El Nino, La Nina events. And the second type of factors on climate change is called the external climate forcing. So it includes for example, natural forcing like volcanic eruption, and also human activity related forcing or the anthropogenic forcing, including aerosol effect and the greenhouse gas effect. So if we take the ensemble mean of these large ensemble climate simulations, then we can largely average out the internal climate variability and then focus on different factors related to the external forcing. Next page, please. So we did that. The model we used is called SPEAR. So this is a new NOAA model, and we use the 13 ensemble members on the different forcing, and we focus on natural forcing like volcanic eruption and anthropogenic aerosol forcing and the greenhouse gas forcing. And this analysis is only for the past 4 decades. On the right-hand side, the top figure highlights the 4 regions by the magenta boxes. So these are the areas where we've been seeing either increase or decrease in tropical cyclone frequency in the coastal region. So the warm color means increasing and cold color means decreasing. On the right-hand side, the bottom 4 figures show the large ensemble model simulation. So these are the ensemble mean tropical cyclone frequency trend. And then we can look for consistency between each pair of these magenta boxes. And here I just want to highlight the US East Coast, which is the last row in the bottom left table. So in the past 4 decades, we've been seeing increasing in tropical cyclone or hurricane frequency along the US East Coast. And the model simulations show that it's mainly forced by anthropogenic aerosol emission reduction. Next page, please. So next, let's focus on the North Atlantic more, but on the other side. So hurricanes can influence the US. It can also influence the Western Europe. And in figure A, we are looking at the epochal hurricane frequency difference after minus before 1995, so in the past 5 decades. The warm color means increase in hurricane frequency. So we have this general increase over the whole basin, and the black crosses show the statistical significance at 5% level. So the increase in hurricane frequency near Western Europe is very significant, but it seems the magnitude is not as strong as the region at lower latitude. However, if we calculate the relative change in hurricane frequency, then we can see that the increase near Western Europe can be as high as 200%. So the relative increase is very significant. Next page. Thank you. So next, we follow the same logic just to explore the reason why we've been seeing this increase in hurricane frequency near Western Europe in the past. And also, we try to project the future. And on the left-hand side, the top figure just give you the reference. So this is the observation. And on the right-hand side, we have this ensemble mean hurricane frequency. So the first four figures show the historical period, and the last two figures show the future projection. If we only look at the top four figures on the right-hand side and compare to observation, then we can see that it's mainly aerosol driven. So that's consistent with the whole basin variation. And if you look at the figure on the bottom left, so it shows the aerosol time series averaged over the US continent, and including the future projections on the different SSP scenarios. And I use soffit to represent aerosol and CO2 to represent the greenhouse effect. And in the past few decades, because of relatively good emission control, so we have this significant reduction in aerosol content. And in the future, it's very likely to be flattened out. And then what we will see in the future is the true effect of global warming due to the increase in greenhouse gas. And if we only use the greenhouse gas to force the future, and then we got the results shown in the bottom two figures on the right. And then you can see in the future on the greenhouse gas forcing, we will have a general reduction in hurricane frequency in the North Atlantic. And it's almost significant everywhere, including the US East Coast and near the Western Europe, if we consider the so-called worst case scenario. Yes, next page, please. So all I just talked about is just the frequency. Then how about the risk? Here, we don't consider any exposure or vulnerability. So next, I will just use the hazard to represent the risk. And here, I use the cumulative cyclone energy as a proxy for TC hazard risk. So these results are for Western Europe. And the first figure shows the time series both for the historical period and for the future for the frequency. So in the past, we have this increase in hurricane frequency near Western Europe, and that's mainly aerosol-driven signal. And in the future, due to the greenhouse effect, we may see this reduction. And for intensity, because Western Europe is at a quite high latitude, so that we don't see any trends in intensity change, both in the past and in the future. And if we combine the two, then for the hazard risk, in the past, we have this significant positive trend, and in the future, we may see a negative trend. And that's mainly the frequency-driven signal for Western Europe. Next, please. So just to summarize, for the historical period, I show some results about the global average change, and we found that this landward migration of a tropical cyclone frequency, and for the North Atlantic, it's mainly the aerosol-driven signal. It's due to the reduction in aerosol emission. And for the future, over the North Atlantic, we may see this general reduction in hurricane frequency, and that's mainly driven by the greenhouse gas forcing. And how about the tropical cyclone or hurricane hazard? For Western Europe, we think there may be a reduction in frequency, and that's a reduction in risk. It's mainly the frequency driven. But how about the US East Coast? I don't show any results for this area, but we can simply think about this question with the figure on the right. So in the future, we will have this general reduction in hurricane frequency over the whole basin. So that's a surprise from the blue distribution to the orange distribution. But what we really care about is those tail events. So if we have the same tipping point, and then in the future, because of this increase in hurricane intensity over the U.S. East Coast, then we may see this increase showing by the red part, the increase in hurricane risk along the U.S. coast, and that is mainly an intensity-driven event, which is different from the Western Europe area. Yeah, so that's all the results I want to share today. Thank you.
Thank you so much, Dr. Wang. That was an extremely nuanced perspective on the future hurricane patterns across the Eastern U.S. and Western Europe. Thank you again for staying roughly on time. Reminder to participants that we're going to be doing a Q&A at the end. Feel free to go ahead and put your questions in the Q&A or chat box, and we'll be happy to integrate those into our panel discussion at the end. So we are delighted next to have a joint presentation by Edwin Sumargo and Mike Souza. Edwin Sumargo is a climate scientist for Massachusetts Executive Office of Energy and Environmental Affairs, and Mike Souza is an agency meteorologist for the Massachusetts Emergency Management Agency. And they'll be presenting on hurricane preparedness strategies in the Commonwealth of Massachusetts, and the talk will feature how the state's preparing for hurricane emergencies, anticipating future climate extremes and public health impacts, and coordinating across agencies. Thank you so much for being here, Edwin and Mike. Looking forward to your talk. Let us know with any problems.
Excellent, thank you. Yeah, so today Mike and I will be presenting on the hurricane preparedness strategies that we have in the Commonwealth of Massachusetts, and obviously that we are working cross agencies to make sure that we are best prepared for this. So next slide. Yeah, so briefly for the outline, Mike will start with kicking off with the hurricane preparedness in Massachusetts, including some review about hurricane facts and the role of the Massachusetts Emergency Management Agencies, and then I will wrap up with the State Hazard Mitigation and Climate Adaptation Plan that we have, also called the Resilience Plan, as well as the State Climate Data Resources that we have. Okay, without further ado, I will turn it back to Mike.
Thanks, Edwin. Good morning, everyone. So just to quickly start us off, let's talk about what's in a name. Hurricanes or tropical systems in general, they're called different things depending on where you are geographically. Here in the Americas, we call them hurricanes, but if you're in the Indian Basin, they're more known as tropical cyclones, and if you're closer to the Asian continent, they are called typhoons. But they're essentially all the same storms, and they all have the same physics and scientific background that goes into making said tropical system. But here we call them hurricanes, and that is when we have a storm system with sustained winds of 74 miles per hour or greater. And there are certain characteristics that make a hurricane what it is. I'm not necessarily going to go into it today, but before we actually get to hurricane status, we first have to become what is known as a tropical depression. This is usually a cluster of well-organized thunderstorms that have some kind of generalized rotation with them, with sustained winds of up to 38 miles per hour. And then in the intermediate stage, it ranges between 39 and 73 miles per hour. This is what's known as a tropical storm. This is a little bit less impactful than an overall hurricane, but it can still be very much impactful depending on where you are and what the actual meteorology of the setup actually is. Next slide, please. And again, depending on where you are also varies your hurricane seasons. And here in the Americas, we typically peak, especially in the Atlantic Basin. Our hurricanes season goes from June 1st through November 30th, but we typically peak around this time, primarily in the second week of August, going through the month of October. And it starts to quickly wane down thereafter. Next slide, please. And so there are a variety of different hazards associated with hurricanes. One that is commonly more known is the high winds that come with hurricanes. And this is essentially how we categorize different types of hurricanes in terms of overall strength. We use what is called the Saffir-Simpson scale to basically rate on how strong hurricanes are, with category 1 being at least 74 miles per hour in terms of sustained winds. These are not wind gusts. This is wind blowing for at least 1 minute or longer. And the minimum, again, is 74 miles per hour. And category 1, the highest it can go is 95 miles per hour. And then in more extreme circumstances, things like what is considered a major hurricane, which would be category 3 or higher. If you go all the way to category 5, that is wind speeds, sustained wind speeds of 157 miles per hour or greater. So if you think about some of these more well-known hurricanes like Hurricane Michael a few years ago, and then of course Hurricane Katrina, those were on the order of magnitude of category 4 and 5, and you can see how much devastation, how much damage actually occurs from those tropical systems. So depending on how strong the hurricane is, it can lead to a variety of different hazards, such as widespread debris. You can also have widespread power outages, and those power outages can last for several days to several weeks. And without electricity, you can have a variety of different health implications as well. Next slide, please. And one of the bigger hazards that is not necessarily talked about all so much is storm surge flooding. And sometimes folks think that storm surge is just the inundation of water on land. So if there's a forecast of, let's say, 10 feet of storm surge inundation, some folks think that, okay, that means that water is going to move 10 feet inland, and that's not necessarily the case. Storm surge inundation essentially means that if you were standing near the beach, water would be, in this case, if you were using 10 feet for an example, it would be 10 feet high. So if you're 6 feet tall, you are 4 feet technically underwater. So this is one of the more devastating impacts of hurricanes, especially for coastal communities. Next slide, please. But if you're in an inland location, like if you're in Massachusetts, especially if you're in the Berkshires or if you're in the Connecticut River Valley, you might not necessarily see storm surge flooding, but you can also have your own version of flooding, freshwater flooding. And flooding from tropical systems is, detrimental in any way, shape, or form. But especially for those inland locations, a lot of times they can be caught off guard with the amount of flash flooding that they typically see. Flash flooding, by definition, is just a very quick and sudden rise in water. Usually you see flooding that is quicker within a 6-hour period. If it's longer than 6 hours, it's usually just called aerial flooding, but flash flooding is usually more immediate. And even after the storm passes, you can still have lingering flooding, especially out in western Massachusetts and in the Connecticut River Valley, where we have some of the more big rivers out there, like the Connecticut River or the Connecticut River at Northampton, the Deerfield River, just to name a few. Next slide, please. And of course, we can also have a few brief tornadoes as well. And even though these aren't the main hazards associated with tropical systems, they still can occur. And usually these are very, very quick. They don't last very long. It's usually less than 10 minutes. And those hurricanes are usually rather weak as well, anything between a EF0 to EF2, which is considered a little bit more on the weaker side of the tornado scale. But when you kind of break it down in more layman's terms, if you're having 157 mile an hour sustained winds, then a little weak tornado doesn't really seem like it's going to cause all that much extra damage. But it still can be impactful, especially if you were in an area, like say if you were in Central Florida trying to get away from the coastline and you had a few tornadoes pass by, that can also be impactful as well. Next slide, please. So why is all this important? Well, all this has to come down to health and safety, especially when we talk about public health and safety. So our friends over at the National Weather Service, they are responsible for forecasting the weather and for issuing different weather hazards to protect life and property. And one of those is issuing different watches or warnings. A lot of folks get these two terms confused, but a watch just means that we have the ingredients for something to occur, in this case, hurricane. So we have the ingredients for a hurricane or a tropical system to occur, and we just have to watch to see if all those ingredients come together. A warning, on the other hand, means to say that there is high confidence that it's going to occur or it's already occurring. And this is essentially the same definition for a bunch of different weather phenomenon, whether that be a tornado or a severe thunderstorm, or it can even be something like a winter storm. Next slide, please. So what is the state of Massachusetts essentially doing to help prepare for when the next big hurricane strikes? And a lot of folks don't necessarily know what emergency management is. And just to bring it in a very, very simplistic term, it's just the overall knowledge and science of just managing emergencies. And it's MEMA's mission to really just support all state entities and the communities through coordination and leadership to prepare and mitigate and respond and recover from all kinds of disasters. Here at MEMA and across all emergency management, no matter where you are, there are different buckets of emergency management, and there's different units. So for instance, our planning unit oversees state plans for how agencies will respond to some kind of disaster. If it's something for hurricanes, for an example, let's say there is a strong hurricane that is expected to come up Buzzards Bay and really impact Cape Cod. And we know that the only two ways out of Cape Cod, if you're driving, are over those very old, over 100-year-old bridges, which are only rated for sustained winds of about 70 miles per hour or so. So if we have a Category 3 hurricane or even a high-end Category 2 hurricane that comes up the coast and impacts us, how are we going to get folks off of Cape Cod in a very safe manner with plenty of lead time in order to do all that safely? So one of those plans that the state oversees is what we call the Cape Cod Traffic Plan, essentially a plan that involves a bunch of different state agencies like Mass State Police, and it focuses on how do we execute a mass evacuation of Cape Cod and the islands if there ever needs to be. We also have a training unit here at MEMA that helps run through those plans with different stakeholders to see, hey, if we ever needed to really implement this in real time, how will we do it? And what are some things that worked well? And what are some things that didn't work well within this exercise? And then for just the general public, we also have a public information unit. And in terms of hurricane preparedness, they help with statewide education efforts. They help with distributing different how to be safe, how to be prepared, different pamphlets and toolkits, and those are also in multilingual languages as well. And we also share these on social media platforms as well, and also repost things from our partners over at the National Weather Service. Next slide, please. And then there are other ways that you and just the general public can be prepared before any kind of tropical system strikes. One of those is being signed up for either our emergency alerts or WEAs, wireless emergency alerts. These are the loud noises that sometimes give you a mild heart attack if you're caught off guard by your cell phone going off extremely loudly. You can also invest in something like a NOAA weather radio, something that's battery powered that you can get updated weather alerts and different information if the power goes out, especially for a prolonged period of time and things like internet is out or telephone communications are out, where other outlets of media and social media, things that we kind of take for granted on a day-to-day basis may not be available. So there are other tools and resources out there to help keep the public informed. Next slide, please. One of the big aspects that we promote here statewide is to really know your zone. Know where you are geographically before a hurricane strikes. Zones in Massachusetts, these are really just the coastal areas that would be the first to evacuate and the second to evacuate, depending on how bad a hurricane may or may not be here in southern New England, and also the timing as well. So, if you're in Zone A, you'd be one of the first to evacuate. In Zone B, you'd be one of the second. So it's always important to know where you live and where you work to know if you're in an evacuation zone. And we have all these resources on our MEMA website. Next slide, please. And with that, I'm just going to leave this slide up here. Feel free to take a picture of it if you like. There are a full list of hurricane safety preparedness tips and health tips on our website. If you just go to mass.gov/MEMA/hurricanes, it will take you right to a full list of all the latest and greatest tips on how to keep you and your family safe. And with that, I am going to kick it back to Edwin.
Thanks, Mike. Yeah, so with the next couple of minutes remaining for us, I will just briefly go over the programmatic updates that we have on the state and switching gear from the weather to the climatic.
Edwin, I think you're muted.
Can you hear me now?
I'm able to hear you fine.
Okay. I'll assume that everyone else can hear me. So yeah, just let me know if you can hear me. But again, this is for more of a long-term climatic standpoint, programmatic update that we have on the state. And then most of you may be aware that we in the 2023 we had the recent mass plan, which is basically an update to the 2018 state hazard mitigation and climate adaptation plan. This is this 5-yearly cyclical update required as a part of the guidance by FEMA. The next one is going to be in 2028. But basically, in this last one, we adhere to to the FEMA guideline as well as the impact and risk assessment proceeded 1 year before 2022 climate change assessment. So there are many actions, priority actions identified through this plan, but I was want to highlight that 1/10 of which revolves around the flooding that that is often associated with many different types of storms, including hurricanes. So next slide. Yeah, so this is some of the snapshots of the initiatives that we had, which include the identification of sources and increase access to resilience fundings for our communities, as well as we want to identify best practices to make sure that everyone is best equipped for the resilience planning and projects as well. So next slide. Yeah, so our main wing in terms of trying to make sure that the Massachusetts population is best prepared for future hazards and disasters like hurricanes is through the Municipal Vulnerability Preparedness Program, or MVP. So to date, since their conception back in 2018, they have awarded over 180 millions to various municipalities and other communities to make sure that they can undertake necessary projects to make sure that their community are resilient. Next. Yeah, so this is some of the core priorities, including making sure that this funding is prioritized for underserved communities like EJ communities, but also that I want to highlight the role of climate change data. Next slide. This is where I sit in. This is to make sure that we also have an office Office of Climate Science that serves as a conduit for climate science and data resources. We are also supported by a climate science advisory panel made up of different subjects and subject matter experts, as well as experts across the board within the weather and climate science to make sure that we are informed by the latest science and best practices. Next slide. Yeah, so this is our climate data hub. We have both for the temperature and precipitation projections and some of the baseline that we have. And on the left-hand side is the map version of it. On the right-hand side is a snapshot of the statistics that you can glean on if you want to look at the specific metrics, temperature and precipitation metrics for the future, for specific decades and areas within Massachusetts. Next. And not to forget, this is not managed by us, but more towards our colleagues in the coastal zone management. They have the Massachusetts Coast Flood Risk Model. This is a coastal flood inundation model informed by future sea level rise, as well as storm surge related to tropical cyclone activities. Next slide. So this is an example that I drew from the recent mass plan. We can see that if you go into that report, you can see how coastal flood is changing over time, but also how it may look like under different climate projections in the future. So in this picture, it is from for a 100-year storm surge in the year 2050 related to the high emissions projections RCP 8.5. Next slide. I know that we have covered a lot of in terms of the health impacts, but I also want to highlight some of the new initiatives that we are working at, also in collaboration with the Department of Public Health and the mapping that we are trying to do to cross-list the health and inland flood hazards and impacts that we have in the state as well. Currently, it's underway. Next. So this is my last slide. Obviously, that many of the impacts on the health are also related to the loss of power and electricity outage. So that's also like a new work that we are working with our Department of Energy Resources to make sure that our grid is resilient towards these kind of hazards and disasters in the future. So, and the next one will be my last. I'll just leave it at that. Thank you.
Thank you both, Edwin and Mike. That was really informative and fascinating to hear about the more practical on the ground side of the hurricane disaster management. So thank you so much. We are now coming upon our last speaker, who is John Morales. He is an atmospheric and environmental scientist at Climadata Corporation, specializing in forensic meteorology and weather consulting. He's also a hurricane specialist at WTVJ NBC6 in Miami, and a climate change columnist for the Bulletin of the of Atomic Scientists. His 4-decade-long career includes civil service as a forecaster for NOAA's National Weather Service, as well as decades of experience as a certified consulting and certified broadcast meteorologist. He was a pioneer in on-air climate communications, providing climate context on his TV and social media platforms for nearly 30 years. He also serves on the board of directors of Florida's Clio Institute, empowering communities to act on climate and champion solutions. He attained his undergraduate degree in atmospheric sciences from Cornell University and a master's degree in environmental sciences and policy at Johns Hopkins University. Thank you so much, John, for joining us today. Looking forward to your talk. Please feel free to unmute yourself and take it away. Thanks, John. Feel free to take it away whenever you're ready.
And if that's the case, let's get going here. Apologies for the breakdown here in the internet. All right. So, this particular hurricane season, I think because of the mix of the changes, the symptoms that we're seeing brought on by the changing climate, which include, amongst other things, a greater propensity for tropical cyclones to reach category 4 and 5 level of intensity. These are the most devastating hurricanes out there, and this is peer reviewed. There is a greater proportion of these tropical storms around the planet that are reaching category 4 and 5 intensity, driven by the warmer and deeper waters that are in the Atlantic. Deeper level of warmth is what I mean by that. So we've got that going on mixed with the cuts to science that we're seeing in general. And that's a much longer conversation in terms of everything else that is suffering beyond just meteorology, climate, and atmospheric sciences in general. But these are very, very concerning. And I think this is a potentially combustible incendiary mix. Next slide, please. So you've seen the headlines. You've seen the headlines since before hurricane season started. We had all living former directors of the National Weather Service, the U.S. National Weather Service, warn that these cuts that we're seeing to NOAA and the National Weather Service, which, let me clarify, have already happened, because I see a lot of pushback on platforms like X that, those cuts are just proposed. They're proposed for the fiscal year 2026. No. These cuts have already happened. All right. So we're down 560 people in the National Weather Service. We're therefore seeing a degradation in the monitoring of current weather conditions, and therefore that impacts our ability to forecast the weather. As far as hurricane season specifically is concerned, I'll just give you an example of the that Robert Atlas, the director emeritus of the Atmospheric Oceanographic Marine Laboratory here in Miami, he has indicated that staffing for the NOAA Hurricane Hunter aircraft is down 40 to 50%. So will those missions fly this year? Not sure. Maybe some will, maybe most of them will, but there is a risk that some won't. So, that again leads to degradation in our ability to observe the ongoing weather. Let's look at the next slide, please. Hurricane season's peak is just starting to ramp up. So, I want you to forget about June and July because it's, with recency bias, most people are saying, well, this is a slow hurricane season. And by some measures, it has been, because the storms that have formed, and we already have the fourth, which formed last night in the Atlantic. It's not a threat to land. The storms that have formed have been mostly weak in terms of wind speeds. So by a measure of longevity and strength, specifically regarding to wind speeds, we haven't seen that much happen. But on the other hand, with a fourth named storm already, and keeping in mind that the average date on which the fourth storm of the year forms is August 15th, well, by that count, we're running above normal. And again, we've got the peak, the heart of the hurricane season ahead of us. Next slide, please. So how many of these things are being degraded? And, we don't have a lot of time here, so you can glance at the image on the left, which is basically the entire scaffolding of observations, feeding numerical weather prediction, feeding specialists at the tropical analysis and forecast branch, at the other branches of the National Hurricane Center, your local National Weather Service offices, your emergency managers. And they've been in the news quite a bit since this tragedy about a month ago in Texas. This scaffolding is being severely impacted by the cuts. So I already mentioned the NOAA aircraft that may not fly. What about coastal radars? Or can they be repaired if they go down, if the electronics technician position is vacant at the local National Weather Service office? What about the weather balloons? Let's talk about weather balloons. We'll go to the next slide here. Actually, before we talk about weather balloons, let me dig in to this aspect of the NOAA Hurricane Hunter aircraft, because if you want an example of what can happen when we cannot properly monitor conditions inside a hurricane because we don't have sufficient tools to do so, you don't have to go that far back. This is my analysis in the Bulletin of the Atomic Scientists after Hurricane Otis slammed the Acapulco area in 2023 as a Category 5 hurricane that was poorly forecasted by the best tropical cyclone specialists on the planet at the National Hurricane Center in Miami. They completely botched this forecast. But the reason they botched the forecast is because they were flying blind, pardon the pun. They were flying blind because in the Eastern Pacific, not as many aircraft reconnaissance missions fly. And by the time a plane got in there, this system was already a Category 3 when they thought it was just a high-end tropical storm or maybe a low-end Category 1 hurricane. And then it continued to intensify due to extremely warm waters it was feeding off of in near the Pacific coast of Mexico, and slammed this region as a Cat 5 with, in my opinion, excess loss of life that would have not happened had it been properly forecast. And it would have been properly forecast had they had the tools to monitor it. So this is what I'm talking about, the combustible mix here. If on the Atlantic side, we don't have the hurricane hunters flying as often because of these cuts, we open ourselves up to this type of risk. Next slide, please. All right, now on to the balloons. So, here's an example from a couple of months ago where each star represents where a balloon was released. The balloons, the weather balloons, which are normally released twice a day from the National Weather Service offices across the country, carry an instrument called a radiosonde. The radiosonde then transmits back data on temperature, on dew point, on pressure, and based on the movement as tracked by GPS, you can therefore calculate what wind direction and wind speed is as it continues to rise up to about 100,000 feet up in the atmosphere. You see those gaps there, especially in the northern plains, in the intermountain west, in the desert southwest. And don't think that, if we're looking at hurricanes in the Atlantic, looking west upstream to where the weather comes from, right, as driven by the jet stream, which generally blows from west to east, don't think that missing this data in the continental US won't matter. It does matter, because with the models, it's garbage in, garbage out. You have to have good data assimilation. You have to have sufficient granularity of the data to be able to produce an optimum forecast. And these days, because these computer forecast models for weather are so good and have improved so much over the decades, well, the specialists at the National Hurricane Center and myself and others rely heavily on these models to predict what can happen in a hurricane. And what's happening, and I just grabbed this image this morning, as you look at the last 90 days of the European global model and the American GFS weather model, and you're seeing degradation in its ability to forecast. And by the way, so, I updated the slide this morning. I've gone back 90 previous days, and it shows the same trend. So the starting point on the left, right, is a lower starting point, right? So it's been extended over the course of all these months since February, pretty much, that we're seeing a degradation in the forecast skill of these models, and that is very concerning. Next slide, please. Okay, let's see if this plays and you can hear it. Well, I can't hear it. And if not, I'll describe what it is. And actually, some of you may have already seen this in social media, but let's see.
Going to turn. John, it's not turning. Listen, I've been on this, since 8 o'clock this morning on social media, and there is a lot of anxiety out there because you don't see it turning, right? When is it going to turn? John, it's not turning. It's coming straight to us. It's going to turn. All right. The turn was never forecast to be on Sunday. The turn isn't even on Monday morning. The turn will come Monday afternoon, Monday evening, into Tuesday.
So the point of me running this video from 6 years ago from Hurricane Dorian, that name has been retired, by the way, and the new tropical storm out there named Dexter, that Dexter is the name that replaces Dorian because it was so destructive for the Northwest Bahamas. You can imagine the level of stress in Florida when that hurricane was very slowly moving straight west across the Northwest Bahamas, which are only about 60 miles away. Okay. High level of anxiety. Do we evacuate? Do we board up? Imagine the costs, right? And the difficulty in evacuating, boarding up, supplies, et cetera, et cetera. When we have confidence in our forecasts, we can do things like this. Okay. And by the way, if you're not used to my level of confidence in presenting forecasts on TV, and you find it a little bit too deterministic, just know I've been, doing this for 40 years, and this is the way I've always done it. But here's the point of all this. I'm not sure I can do that this year. I am not sure that I have the ability to be able to confidently get on camera and speak to my audience and let them know that they can rest assured that it's not coming, or conversely, that it is coming and that they need to prepare. There is a greater level of doubt. I frankly think that when we look at these hurricane forecast cones of uncertainty, the track forecast, which is shaped like a cone, it's going to have the same width this year, maybe a little bit narrower than last year. But frankly, it should look more like the cones of the 1990s, right? I mean, for example, when Hurricane Andrew was offshore east of the Bahamas, the cone included the entire state of Florida, because we didn't know if it was going to St. Augustine or going to, Islamorada in the Florida Keys. And then everybody needs to prepare, and everybody needs to sweat it out. And the expense is enormous, right? And the loss of life is potentially enormous too. So we'll fly through these. I already told you hurricanes are getting stronger. Next slide. We know attribution studies show us that even in the hurricanes from last year, due to the incredible warmth in the ocean, Hurricanes Milton, Beryl, and Helene ended up being one category stronger, attributed to the changing climate, attributed to climate change. And the next point is really important. Let's look at the next slide, please. Well, that's Milton, which went over record-setting waters, made 700 times more likely to be at that temperature than in the absence of climate change. Next slide, please. And of course, the stronger hurricanes lead to higher costs. There's a humongous difference between a Category 1 hurricane and a Category 4 hurricane. Because yes, the rain can be horrific in either one, and you can have a lot of deaths from floods, but because the windstorm and the storm surge can be so much higher in these Cat 3, 4, and 5 hurricanes versus a Category 1 hurricane, that's where you see the increasing costs of life and property. Next slide, please. So, let's skip this one. No time for this. Next slide. You may have heard that, maybe this hurricane season won't be that bad because sea surface temperatures are not as hot. And early in the year, maybe they weren't so hot. But right now, they're only behind 2023 and 2024 in terms of warmth. Next slide, please. And as far as the Atlantic's main development region, actually, this is the North Atlantic in general. They are also the third warmest on record, only behind 2023 and 2024. So the sea surface temperatures are super warm, and we are poised for another potentially destructive hurricane season. Next slide, please. The forecast, this is the forecast from various entities, a couple of dozen of entities here. Some are academic, some are private, some are government. The average number of hurricanes being forecast for this year is 8. We've had 0 so far. The average date for the first hurricane to form is August 11th. So don't think that we're behind schedule on hurricanes. The average first hurricane of the year, based on the 1991 to 2020 climatology, is August 11th. We are not running behind schedule, and there are 8 hurricanes forecast for this year. Next slide. And I think this concludes my presentation. Apologies, it's 12:13, but hopefully we have enough time for questions.
Yep, this was perfect. Thank you so much, John. This was really fascinating, and very much appreciate your approach to climate communication. I think that's a really important aspect of this that often gets overlooked. So I think we're ready to start the panel discussion now. So if all the panelists could kind of get ready in case we have questions coming your way. We've had a good number of questions coming into the chat as folks were speaking. So we'll try to pull those into our Q&A. A lot of those are for particular speakers, but maybe I was thinking it might be good to start off the session with a more general question that various folks might be able to chime in on. So I've got a couple of questions that are kind of for everybody, and then maybe we'll hone in and take some questions for particular speakers from the audience. So I think a lot of you touched on this during your individual talks, but I was wondering if we could kind of have a broader discussion on what are the most effective adaptation, preparedness, forecasting, or crisis management strategies to mitigate the health impacts of hurricanes? So we've heard a lot about forecasting, a lot about health impacts, but how can we sort of pull together all the evidence that's out there to tell us from what we know right now, what are the most effective steps we can take to mitigate hurricane health impacts? And any of the speakers, feel free to unmute yourselves and answer if you have thoughts.
I don't mind going. I think one of the most important aspects regarding just overall hurricanes and best ways that you can be either informed or prepared is just overall education, very similar to what this whole speaker series is about. The more you know, the more power you have, and knowledge is power. If you can understand what your risks are and what these storms can bring. You know, it's one thing to hear about it on the news and hear about what's going on in Florida or hear what's going down in Southern Appalachia or wherever the case may be. When you hear about it, it's like, oh, you know, it's not as real as when it happens to you. And everybody thinks it can't happen to them. And when you look at the history here in Southern New England, you know, we've had 25 tropical systems impact us over the last 100 or so years. And that doesn't sound like a whole lot. But we have had 2 major Category 3 hurricanes, the hurricane of 38, which was before they even started naming hurricanes, and then Hurricane Carol back in 1954. And ironically enough, that year in 54, we had Carol, and then 2 weeks later, we had a Category 2 impact us in essentially the same areas, which was Hurricane Edna. And if that were to happen today, I think you'd get a lot more awareness about climate change and how these storms are not necessarily becoming worse in nature. It's just the more severe storms, as John mentioned earlier, are just becoming more frequent. You're going to start seeing a higher frequency of 4s and 5s hitting communities, and that's going to have a cascading effect on everything from public health to what we pay for in terms of insurance, flood insurance, commodities, and things of that nature. So I think just having a general understanding of what the trends look like over the coming years and how you and your families can be prepared is probably one of the more important things that I can think of that folks could do to help better themselves for these type of events.
So maybe I can briefly follow up from Mike there. That's an excellent overview. Also, I want to highlight is that oftentimes when I'm working, wearing my Set Climate Office hat here, whether it's talking with the other agencies or anybody outside from the state agencies and general populations, sometimes it's from the communication standpoint, it's helpful to give them a not just about like what the hurricane can do or whether the trend is increasing or not or something like that, but also to use like a storylines, like what resonates with them more recently. So like what Mike just did just now, bringing out some of the examples from the recent past or the well-known examples from the past, how it looked like, and then how something like that may change in the future, maybe more devastating in the future. Usually that will resonate well with the general audience.
Yeah, sort of getting back to the climate communications piece that that John talked about. It's a super important but often overlooked factor, I think.
Yeah, I totally agree. I'd add on, like, it's so important to like increase awareness and knowledge. And from communities I've talked to, they've emphasized that they really want the knowledge kind of like before, during, and after, and because there are some long-term effects to kind of like really continue getting information out during different time periods and like really effectively getting information out, especially in different languages, especially in rural areas, and talking about, you know, immediate hazards as well as, you know, how to get your well water tested and what to do about mold.
Thanks, everybody. So kind of following up on that, what kind of resources or data have you all noticed that are lacking and might be needed to advance research, forecasting, or preparedness efforts related to hurricanes and health? Aside from the things that are had already existed but have been rolled back in recent months, are there any sort of resources or data that you think would be critical to advancing research and practice in this space?
I'm going to take that on because I just want to broadly, warn everyone, and at the same time bring a ray of hope to all this, that the budget proposal from the White House for the 2026 fiscal year included such a severe cut to NOAA that all of their national labs would be closed. This includes, just to name a couple, the National Severe Storms Laboratory in Oklahoma, which has helped us, better warn for flash floods, There's social science involved in this, so how to better communicate and deliver these warnings, what the call to action should be, what to expect in terms of actual actions from a family or a population when these warnings are issued. They help us learn about severe thunderstorms and tornadoes. In Miami, AOML, which I mentioned during my talk, within AOML is the Hurricane Research Division. They've helped craft some of the computer forecast models that are specific for hurricanes. They've helped us understand the physics of hurricanes so that we can become better at forecasting their intensity, which we're not so good at, by the way. I mean, we're great at forecasting track, but intensity has been a bigger challenge. Up in Princeton, New Jersey, the Geophysical Fluid Dynamic Lab, GFDL, also to be shut. So, I mean, those are just 3 examples. By the way, all the monitoring of carbon dioxide that's US-based would also be shut because, if you can't measure it, it's not increasing, right? Now, the ray of hope. Congress is pushing back on this substantially. So in committees, appropriations committees and such, you've seen significant pushback on this. The bills that are being crafted for the budget and such do not show that level of severity in the cuts. So, again, they have the power of the purse, but at the same time, they're, feeling the pressure from, I'll just leave it at that. I'll leave it at that. So, fingers crossed, but this is where we're at.
Any other thoughts from the, specifically maybe from the research end, about other resources or data that would be helpful to advance research efforts in this space?
I just want to chime in that. So I think not only from the government side, but also from the private sector, I think there should be, it would be wonderful if there's a deeper collaboration about data sharing, especially about the exposure. So I talked to a few friends in private sectors, and I want to kind of introduce our new methods about the exposure risk estimate. And what I was told very frequently was that, okay, so we have much better exposure data than you are using, and but they also don't talk to each other. So I think it can really benefit both academia and the private sector if we have a better platform just to share this data.
That's a great suggestion, and I assume maybe Dr. Quist can speak to this, but I assume better exposure data also means better health impact assessments.
Yes, certainly. The exposure data is like such an important piece. And yeah, as I mentioned, it's just really hard to know where people are during storms and really how to measure the health effects. And so, ideally you have an amazing cohort that you're able to enroll and get information from everyone about where they were. And, in disasters, that's not, the first priority. I think a lot has been done with data that's available. And I think there is certainly room in data that's available and in additional cohorts.
Thanks, everybody. So maybe we'll get into a few of the more specific questions from the audience. One that I think brings together a couple of threads from this discussion is from Elaine Bertolini. And this was posted during John's talk, but I think relates to a few folks' discussion topics. Does the greater degree of uncertainty in forecasting mean that larger populations may need to evacuate, which then might prompt additional mortality risk, as Dr. Quist indicated, that sometimes the evacuations themselves can be harmful to health?
I can take a stab at that one. you know, weather forecasting has gotten a lot more advanced in, let's just say, the last even 10 years. You know, never mind the last 30 or more years. So even you know, when you hear about, you know, all the cuts of NOAA, and as John talked about earlier, you know, that there comes a risk with, you know, there being less available data for us to use. And how weather prediction essentially goes is, you know, we're trying to predict the future, which isn't easy, because the analogy I like to use is that if it was straightforward, everyone would have been rich yesterday, because everyone would have easily forecasted what the winning lottery numbers were going to be. But that's way more difficult, you know, in real life. And so us meteorologists, we have several tools in our toolbox that we use in order to forecast where hurricanes are going to go and what the impacts are going to be. You know, we're not going to get it right every single time. And so, you know, the folks, especially those at the National Hurricane Center, they're really the experts in terms of hurricane forecasting. And when you see what they call the cone of uncertainty, which is the probabilistic track of where hurricanes may or may end up going, statistically, the Hurricane Center has, you know, had it doesn't necessarily sound like a high score, but usually the hurricane tracks within that cone about 2/3 of the time, so about 67%, which, when you think about it, is actually a pretty good score when you're talking about, you know, forecasting where a hurricane can go, because there's a lot of different aspects on what plays in that hurricane. You know, what are the upper level winds doing? Is it, you know, helping to deteriorate the storm, or is it helping to move it into a certain area? There are a lot of different things. Which weather model is more correct than the other? So we have to try to, you know, figure out all this different data, and then how to properly communicate it to the public so they fully understand what, you know, their risk is. Now, I know that there are, you know, plenty of other weather phenomenon, like, you know, tornadoes or severe thunderstorms or even winter weather events, you know, where, you know, we can say, hey, you know, we're expecting a certain outcome, and then it doesn't happen. And then, you know, sometimes that can cause some deaf ears, and, you know, some burnout, especially if, you know, you're, let's say, like in, you know, one that comes to mind, if you're, you know, a Florida resident in 2004 and you got 4 back-to-back major hurricanes, basically about a week apart, you're going to get some type of burnout. You know, and those were all, you know, pretty heavily impactful storms. So, you know, if you think about it from, you know, that point of view, you know, there certainly can be some burnout, you know, just, you know, mental fatigue. And even when you bring it more to, you know, today's world, you know, 20 or so years later, how many times are you going, you know, if you're a resident in Florida or somewhere on the Gulf Coast, how many times are you going to rebuild after a major hurricane? How many times can you lose things that can't be replaced, like home movies and pictures and things of that nature? Grandma's favorite necklace. How many times are you going to replace all that? And then the cost to, you know, rebuild afterwards, whether it's insurance or whether it's out of pocket, all of that plays a role on health as well. Maybe not, you know, physical health so much, even though it still does. And I'm not a health expert by any means, but definitely, you know, I can see there being, you know, mental stress and mental health effects from that, if that answers that question.
Thanks. I was also wondering, Mike and Edwin, if you could speak to a question that came in about, oh, I see we're out of time. Maybe just quickly, if you could weigh in on how connected or isolated are emergency management agencies from state to state, and how much do they coordinate efforts, and how helpful or productive is that in response to tropical storms?
Absolutely. So states do talk to one another. You know, we hear about FEMA a lot, the federal agency responsible for emergency management, and how they will come in after a major disaster. FEMA is really just it can be thought of in a very simplistic term as they're kind of like the last like hoorah. They are the extra support when all the other resources have gone out. So if it's like you know, let's say if Massachusetts experienced you know, a severe hurricane, Massachusetts will exhaust its resources first, and then we'll call, for nearby states for assistance. It's a PAC. It's called EMAC, Emergency Management Assistance Compact. And what they will do is they will help send some folks and or some resources to help fill in where Massachusetts needs to be. And also FEMA will come in and help that as well. So there's different levels, but in the short aspect is that states are interconnected with one another, and all disasters start and end locally. So it's not like FEMA comes in and says, hey, we're taking over the show from here on out, or another state. It's not like that. So states do contact and stay in touch with one another, and in some cases they do hold exercises. What happens if there's a big enough storm where we have to kind of all work together. So there are exercises that I've helped plan meteorologically as well, that go along with that.
Very interesting. Thank you. This has been a really fascinating discussion. Thank you so much for very informative presentations. I see we are at time now, so I think I'm going to wrap up. But for the audience, thank you again for all the questions you submitted. Feel free to reach out to speakers if you have more detailed questions on their presentations. And I hope everybody will join us for later sessions in the day. Next up, we have the networking session from now until 1. So please join us there if you're able. Looking forward to seeing everybody at some of the later sessions. Thank you again to all of our panelists. This was a fantastic session. I learned a lot. And thanks, and hope to see everybody later today.